In this video, we're going to write the equation of the graph in factored form, so we need the x-intercepts. As a reminder of what the equation looks like in factored form, we have y equals a, that lead coefficient again tells us if it opens up or down, and also if there's any scale changes. X minus c and x minus d are the x-intercepts, or c and d are the x-intercepts of the graph. So when we look at this graph, we have an x-intercept of -4. We put it into the asylum, and it becomes a +4. Our other x-intercept is a +5, so when we put that into the asylum, we get a -5. Remember, we found the x-intercepts by solving, by setting it equal to 0. So we're kind of unsolving when we put them into the equation. Next, we grab this other point here, just like we did for vertex form. Substitute the 6 everywhere there's an x. And we substitute our -3 for y. And our goal is to solve for a, just like it was on the vertex form. So simplifying this, we get 6 plus 4 is 10, times 6 minus 5 is 1, or 10 times 1 gives us 10a. Dividing both sides by 10, we get our a value. And it does match the graph. The graph opens down, and our a value is negative, so that makes sense. Substituting that back into the equation with the intercepts, we get x plus 4 times the quantity x minus 5. All right, last piece is writing the domain and range. It's a quadratic function, so that's easy. Domain is all real numbers. Range, we will need the vertex. In this case, we don't exactly have the vertex from the graph. We didn't need it for factored form. So I'm just going to look at the graph and estimate about where that vertex is. And it looks to me like it's at about 4. So we're going to do y is less than or equal to, because our graph opens down, and the y-coordinate of our vertex looks like it's at about 4. One more, I do recommend that you watch this one, even if the last one made sense to you. This one's a little bit different because now we've got the x-intercept as our vertex. So we only have one x-intercept, which is a little bit different than the last one. So we're going to start by setting up that same equation, y equals a times the quantity x minus c times x minus d. All right, substituting that one x-intercept in for both c and d, and then we're going to use our other ordered pair. We're going to substitute -5 for both x's and 3 for our y to solve for a. So in this case, we got -5 plus 2 is -3, times -3 is 9. So we have 3 equals 9a. Dividing both sides by 9 and simplifying, we get an a value of +1/3. So that does match our graph. Our graph opens up. Writing our equation, we get y equals 1/3 times the quantity, and I'm going to go ahead and simplify this to vertex form. Sorry, that should be a 2. All right, so quantity 2 squared. Oops. All right, domain. Quadratic function, domain is all real numbers. Range has to do with the y-coordinate of our vertex. Our graph opens up, so y is greater than or equal to, and the y-coordinate of our vertex was 0. I'm going to give you your U-Try question now. Even though I haven't taught you how to write the equation in standard form, what you do is you start with either vertex or factored form, and then you convert it to standard form by multiplying. So if it's in vertex form, you're going to square the binomial. You will not distribute the square. You will multiply it by itself and FOIL. If it's in factored form, you'll already see the foiling that you need to do, and then simplify as needed. So as a reminder, standard form is y equals ax squared plus bx plus c. If you get stuck anywhere, just let me know and we'll go over this tomorrow.